Hey, I want to do a quick video from section 3.4. So we're just solving equations, rational and radical equations. Let's do number 4 here. Let me make it a little bit bigger, and let's see here. So what the strategy is, we want to get rid of these denominators. These denominators are in the way, turn it into a more normal quadratic-looking equation. So what we can do is multiply by kind of the least common denominator. The least common denominator is actually x plus 1 times x minus 1. This is actually the x, this factors, that right there, that factors into x minus 1, x plus 1. This is going to get rid of everything. So we're going to multiply this on the left. So it has one of those denominators. And then we're going to hit all of that across there. And then we're also going to hit this side as well. X plus 1 times x minus 1 times 20 over, and let's go ahead and factor that denominator so we can see it a little bit better. So so when this distributes in here, it's gonna cancel just the x plus 1 with that one, and then this one's gonna cancel with that one, and this one cancels completely with that, and this one cancels completely with that. So what do we have in the end? So the 2 hangs around, and we still have an x minus 1, and then the 1, well, the 1 hangs around, but just multiplying, and so the x minus 1 goes away, so you're left with x plus 1. And then the right-hand side just has a 20. And so now we have a linear equation. So you've got to distribute. There's not much to do with that second. He just drops those parentheses. There's nothing to distribute. The right-hand side is, let me get rid of that equal sign. The equals is in the middle here. The right-hand side is 20. So we bring the 1 over there. We get 19. Sorry, we got the minus 2 as well. So let's go ahead and bring the 2 over. That's 22 minus, that's 21. So it took care of all of those, and then you've got a 3x, and so x is clearly 7. Now you need to make sure we didn't get a redundant solution or erroneous solution, so you got to make sure that when you plug it back in, you don't get a division by 0 in the original equation. No problems there, so we're going to go with 7. All right, let's do another one. Let's do a radical equation. This says the square root of 4x minus 13 equals 1. The strategy here is we're going to square both sides. Let me put it on a separate page here. So we got the square root of 4x plus 13 equals 1. All right. Make sure 4x minus 13 equals 1. So erase that. All right. So now we got our question. So what we're going to do is we're going to square both sides. So when you square a square root, the square root goes away. But we have to be cautious. Sometimes erroneous solutions are created. It's not going to actually happen on this problem, but you do have to be cautious. Now we're going to add 13 to both sides. And so we get 14. And so in this case, x is 14 quarters, which reduces to 7 halves. Now let's do one with an erroneous solution. That would be the next one. Square root of x plus 2 plus 2. Square root of x plus 2 plus 2 equals 0. Now you can tell right away that this has a problem, an erroneous solution. When I say erroneous, it's just not, the solutions are imaginary, they're not real. And the problem is right here, you can't take the square root of a number and get a negative number. That by definition, the square root is positive. So, but let's go ahead and go through the motions. So you square both sides, you get a negative 2 squared, the square root goes away, the negative goes away, you get a 4, and you get x equals positive 2, and it looks very reasonable until you check your answer. So let's check our answer. 2 plus 2 plus 2 is not 0. That is square root of 4 plus 2. That is 2 plus 2 is equal to 4, which is not our right-hand side of 0. So this is not a solution. In fact, there are no real solutions for this one. So that's why I said there's no solution. So no real solution. Okay. Anyway, that's it for now. Have a good day.